recording is in progress. So, good afternoon, dear students. Welcome to another session on modern information retrieval. So, today we will be talking on the second chapter. Okay, we'll be talking on the chapter 2, that is Introduction to Modeling. So, yesterday we have discussed about the basic fundamental concepts of modern information retrieval. So remember one thing, uh, in modern information retrieval there are two concepts. The first concept is data retrieval. So if you want to retrieve data, you can straight away go with your RDBMS. Directly you can use our database management system. Any database management system you can certainly use. Information is the one which is processed, and if you want to retrieve this information, it has to be some heterogeneous sources. So remember one thing, whatever the data that you are retrieving from RDBMS, so they are all structured data. You can see they are all structured data which is having proper structure. So from information retrieval, whatever the data that you are retrieving, they are all non-structured, or I can say they are semi-structured, like the XML and JSON kind of structured, semi-structured, or you can see they are unstructured data. So they are semi-structured or unstructured data. If you want to get it from this modern information retrieval, so we make use of this techniques. So here we discussed how the data is, or the information in the form of a document is stored in the repository, and how it is retrieved in the yesterday's class we have seen. So today, in continuation to that, we will be discussing about these three things. That is the taxonomy of information retrieval models. So in order to retrieve the information, so we need some models, like we have to model the entire storage structure and also retrieve the data. So model our query and retrieve the data. So retrieval as well as a search during ad hoc filtering, formal characterization of information retrieval models. So these are the three things are lined up for today's agenda. So taking on to the modeling, what is exactly modeling? If you see, the traditional information retrieval systems usually adapt index items to index and retrieve documents. So indexing is one of the very important concept in the retrieval process. Of course, in a restricted sense, an index term is also called as a keyword, or a group of related words, so which has some meaning of its own. In its more general form, an index term is simply any word which appears in the text of the entire document in the collection. Of course, retrieval is based on this indexed term. So when you take any document, so this index, whatever you see is the index. So index contains some words so that are most frequently used, that will quantify this document. And of course, for instance, Let us take one instance. A retrieval using index term adapts as a fundamental foundation uh, the idea that the semantics of the documents of the user information need can be naturally expressed through a set of index terms. It is just like a query. Say, for example, in ChatGPT, whatever you give the prompt, so that is nothing but your query. This query, based on the query, what happens, a particular information is retrieved, or the same way in Google search, whatever the search query that you are going to give to the Google, so it is going to give either the PDF file or a Word file or image file, whatever it is. So clearly, this is a considerable oversimplification of the problem, because a lot of semantic in the document or user request is lost when we replace its text with some set of words. So moreover, matching between each document and the user request is attempted uh, in this very impress space of index terms. So thus it is no surprise that the documents retrieved in response to the user request expressed as a set of keywords are frequently irrelevant. Most of the times we may get irrelevant documents also. So if uh, the user also consider that most users has uh, no training in formulating these queries. The problem is still worsen with potentially disastrous results. So the frequent dissatisfaction of the web users with the answer they normally obtain is just one good example of this kind of fact. So clearly, the central problem regarding information retrieval is the issue of predicting which documents are relevant to the query search and which are not. So that is the first thing. Such a decision is usually depend on the ranking algorithm, which attempts to establish the simple ordering of the documents retrieved. So, as yesterday we have seen, so in the diagram, once you give your query request for search, what happens? The various software agents will process that and will retrieve. And many software agents works behind your query, and many will retrieve your documents, web pages, all those things. So once it retrieves, based on the rank, they are listed. So this ranking is the very important thing. So it is going to give the search results. So some pages, some documents will come first, some documents will come second, some documents will come third. So this is called ranking. So documents appearing at the top of this ordering are considered to be more likely to be relevant. Thus, ranking algorithms are at the core of the information retrieval system. So that is very, very important point that you have to consider. So these are the four important points that we are about to discuss. So, in order to make this ranking algorithm work, we we model. There are actually uh, 15 models are there. So, what is there in your syllabus? Only that we will going to discuss. So, ranking algorithm operates according to basic premises regarding the notation of the document relevance, distinct set of uh, premises regarding document relevance, yield a distinct information retrieval model. The information retrieval model adapted determines the prediction of what is relevant and what is not relevant. So that is to be discussed by this system. And of course, when you think of the taxonomy of information retrieval model, so when user starts working with this tasks, so he has retrieval ad hoc filtering, so he is not sure. Sometimes he browses, so while browsing he get flat structured guided and hypertext data. But when he is working with ad hoc filtering, very very important, there are two models that he will going to use. One is the classical model, another one is the structured model. It is non-overlapping list. That is, we certainly use proximal nodes. So here, for your syllabus, you have only this, the classical models. That means you have a set theoretic, algebraic, and probabilistic. So the three classic models in information retrieval are your set theoretic. They are also called Boolean, and of course algebraic. They are also called vector, and the probabilistic. So probabilistic is based on probability theory. So in a Boolean model, documents and queries are represented as a set of index terms. We say that the model is set theoretic. So in vector model, documents and queries are represented as vectors in a t-dimensional space. So this is very very important. Further we will see how this is. Thus we say that the model is algebraic, and of course in a probabilistic model framework for modeling document and query representation is based on probability theory. Thus the name indicates we say that the model is probabilistic. So over years, alternate modeling paradigm for each type of classical model, that is theoretic, algebraic, and probabilistic, have been proposed. Regarding alternative set theoretic models, so we distinguish the fuzzy and extended Boolean models. Regarding alternate algebraic models, we distinguish the generalization vector, the latent semantic indexing, and the natural neural network models. Of course, regarding the alternative probabilistic models, we have distinguished the interface network and the belief network model, as you can see in this particular diagram. So the entire taxonomy is explained. So besides these reference model, the text content, they are totally working on the text content. So the model might also allow references to structure normally present in written text. Of course, in this case, we say that we have a structured model. We distinguish two models for structured text retrieval, namely non-overlapping list models and proximal node models. So these are structured models. And of course, the user task might be one of browsing also. Just instead of retrieving, just browsing, just see, that's all. He just want to click, click, click. He want to see what is there. He's not searching. So he follows that link, hyperlink. So you can see this in the diagram. We distinguish three models for browsing, namely just flat files. So flat file structure and guided structure guided and hypertext. So we emphasize that IR model, that is information retrieval model, like Boolean, vector, and probabilistic. The logical view of the document. Yesterday we have seen how exactly the logical view of any document stored on the net or internet is represented. They are in the form of full text plus set of index terms. So I just wrote the same thing. So if you have a document, so it is associated with the index. So usually based on this index terms only, the document is recognized or retrieved. So these are the things that we come across. So along with that, we also have the logical view of the documents. In fact, to understand more precisely, the classical model, that is a Boolean model, and the extension of that is a set theoretic. Documents and queries are represented as set of index words in the Boolean model. So if that word is present, it is 1. If it is not present, it is 0. So as actually these models work based on mathematical theories. So as a result, the model is set theoretic. So you can have a set of documents that are matching with the keyword. Keyword is nothing but the searching word. So it is a kind of set theory. You can see set theory. And the second type is what the classical model, vector model, which is extended algebraic model. So here documents and queries are represented as vector. Vector is nothing but an array. So a two-dimensional array. So it is represented in two-dimensional array. That's maybe t dimension. You can certainly use a t-dimensional array space in the vector model. As a result, the model is algebraic. And the third model is classical model, that is probabilistic. So the framework for this model documentation is just prediction. That's all. Predict whether this word may be present or not. When you are talking about a mouse, so if there is a document with computer terms, so you are having probabilities more than 60-70 probabilities are there. 60%, 70% probability is there to have some content about this particular mouse. So it is a prediction. It's a predictive model. The queries are represented in the probabilistic model that is based on the probability theory. As a result, the model is totally probabilistic. So that is the thing that you have to understand. And of course, you can understand here this logical view of documents. So when you think of the classical theoretic model, they are mainly used for retrieval. And this is based on the index terms. So it makes use of this index terms for the thing. And of course, you can certainly see with respect to browsing, again, browsing also follows the same index terms for extracting the flat files. And when it comes to full text, so if you want to retrieve the full text, so you certainly use set theoretic model as well as algebraic model as well as probability model. All three you will use for retrieving the complete text. So here flat files as well as the hypertext are used. Full text plus structure, you make use of structured model. Here, structure guide hypertext is certainly used. So this is the logical view of the various documents that are used uh, in the taxonomy of this information retrieval. And when we think of ad hoc filtering, ad hoc, acquiring, ad hoc retrieval and filtering. So in a conventional information retrieval system, the documents in the collection remain relatively static while new queries are submitted to the system. This operational mode has been termed ad hoc retrieval in recent years and is the most common form of user tasks. In fact, a similar but distinct task is one in which the query is remain relatively static while new documents come into system, and of course they leave. So uh, for instance, this is the case with the stock market, with the news wiring services. The operational mode has been termed as filtering. So in filtering tasks, what happens? A user profile describing the user performance is constructed. Such a profile is then compared to the new incoming documents. Of course, in an attempt to determine uh, which are those which might be of interest to a particular user. For instance, this approach can be used to select a news article among thousands of articles which are broadcast every day. So, other potential scenarios for application of filtering include the selection of preferred uh, judicial decisions, or the selection of articles from daily newspapers. Of course, typically the filtering task simply indicates to the user the documents which might be interest of the user. Of course, the task of determining which one are really relevant is fully reserved to the user. Not even a ranking of the filtering document is provided. A variation of this procedure is to rank the filtered documents and show this ranking to the user. The motivation is that the user can examine a smaller number of documents if he assumes that the one at the top of ranking are more likely to be relevant. This variation of filtering we certainly call it as routing. So you can see in routing, the query remains relatively static, but the new documents are added or come into the system. So that is the thing. And of course, in ad hoc searching, what happens? The documents in the collection remain static, but what happens? New queries, so different queries, such as the same document, in different forms. So this is, I think, you can understand ad hoc, searching, ad hoc retrieval, and the routing retrieval. So this is a difference. And of course, even if no ranking is present to the user, the filtering tasks can compute an internal ranking to determine potentially relevant documents. For instance, documents with a ranking above a given threshold could be selected. The other would be discarded. Of course, you can see those are within the threshold of ranking. So they are considered okay. So it is a totally mathematical. So if you calculate the rank, if it comes, okay, then you select this document may be there. So we will see that in the next chapter, how to compute ranking, how to make it selective. So understand that any information retrieval model can be adapted to rank the documents, but the vector model is usually preferred due to its simplicity. At this point, we observe that filtering is really a type of user task or operational mode, and not a model of information retrieval. Thus, the task of filtering and the information retrieval model adapted are orthogonal aspect of an information retrieval system. In a filtering task, the crucial step is not the ranking itself, but the construction of user profile, which truly selects the user preferences. Many approaches for constructing user profiles have been proposed, and here we briefly discuss a couple of them. A simplistic approach for constructing a user profile is to describe the profile through a set of keywords and require the user to provide the necessary keywords to understand about that particular user. The approach is simplistic because it requires the user to do not too much. In fact, the if the user is not familiar with the service which generate the upcoming documents, he might find it fairly difficult to provide the keywords which appropriately describe his preferences in that particular context. Furthermore, any attempt by the user to familiarize himself with the vocabulary of the upcoming documents might turn into tedious and time consuming exercise. Thus, despite its feasibility, requiring the user to precisely describe his profile might be impractical. So, a more elaborative alternative is to collect the information from the user about his preferences and use his information to build his own profile dynamically. So this can be accomplished, uh, you know, using various keywords, and of course the login, and sometimes user also gives some feedback to the system, so wherein you understand, and of course it is the cycle to understand his profile. So that's the thing. So when you think of formal characterization of any information model. So if you want to represent information model, so we have set up the fundamental premises which form the basis for ranking algorithm, determine the information retrieval model. So information retrieval model characterization, you can certainly understand. So there are several information retrieval techniques, of course, types that can help you with the process. And of course, an information retrieval comprises of following four keys. The first one is D, that is a document representation. We certainly call this information retrieval model as a quadruple D, Q, F, and R. So, what is D? D represents the document, Q represents the query, F represents the framework, and R represents the ranking function. In fact, the D represents a document is a set composed of a logical view of the documents, where Q represents the query is a set composed of logical views or representation for the user information needs. Such representations we call it as queries. F is a framework to match and establish a relationship between the document and Q. So in other words, F is a framework for modeling the document representation and queries and their relationships. So that is the thing. So you can certainly understand the framework establishes the relationship between your document and the queue. So that is the thing. And R contain Q of I and D of I. So Q of I is a query instance, D of I is a query instance. So it is a ranking function that determines the similarity between the query and the document to display the relevant information. A ranking function that determines the similarity between the query and the document to display relevant information. In other words, R Qi comma Di is a ranking function which associates a real number. So it will return a real number. Remember, it returns R of Q of I, comma D of I. So where Q of I and D of I are query instance and document, it will return a real number. It returns a real number. So this is a ranking function. And where your Q of I belongs to a queue, a set of query, and same way D of I is also belongs to, so it also belongs to D. So set of document representation. So when you send any query and document, what happens? The ranking function will defines an ordering among the documents with regards to the query, and it will return some number. So based on number, you will decide whether the relevant content is present in this document or not. This is what the information retrieval is all about. And of course, to build, we think first the representation of the document, and for user information needs. So given these representations, we then conceive the framework in which they can be modeled. And of course, this framework should also provide the intuition for constructing ranking function. And if you look at an example for a classic Boolean model, the framework is composed of set of documents and the standard operations that can be performed on these sets, maybe union, intersection, subtraction, all those things. For a classical vector model, the framework is composed of the t-dimensional vector space and standard linear algebra. So that is the thing for linear algebra operations on vectors. And of course, for classic probabilistic model, the framework is composed of sets and standard probability operations, and also very important Bayes theorem. So you understand Bayes, Bayes theorem, very Bayes theorem. So Bayes theorem we will study. Bayes theorem we'll study in the later part. So which is very important thing. And of course you can see each document is described as set of represented keywords called index terms. So numerical weights to distinguish the relevance between these index terms. And of course, in classical model, we use Boolean, vector, and probabilistic. So it is very difficult to decide the decide the importance of the keyword is difficult and tricky. So for this, so we make use of the ranking function. For that, it is required to understand the terms, semantics, as well as its distribution in all the documents. So, for all these things, numerical weights are used to quantify the importance of the index terms for describing the document content. So, that is the thing. So, when you look at this particular you know thing, so here, so given a set of index terms for a document, we notice that all the terms are equally useful for describing the document content. In fact, there are index terms which are simply vague, vaguer than others. So, deciding on the importance of the term for summarizing the content of the document is not a trivial issue. Despite this difficulty, there are properties of an index term which are easily measured and which are useful for evaluating the potential of a term as such. For instance, consider a collection with hundred thousands of documents. A word which appears in each of the document of the 100,000 documents is completely useless of that as an index term, because it does not tell us anything about which documents the user might be interested in. And of course, on the other hand, the word which appears in just 5 documents is quite useful because it narrows down considerably the space of documents which might be of interest to the user. Thus, it should be clear and distinct index term having very relevance when when used to describe that particular document content. So this effect is captured through the assignment of the numerical weights to each index terms of the document. So let us look into some mathematical way of description. So let P be the number of the index terms. So in the system, so K of I be one of the generic index term. So you have set K which contains all the key index terms K1, K2, K3, Kt. So is set of all index terms. So and of course a weight of Wij, which is greater than 0, is associated with each index term to K of I. So for every index term has a weight of a particular document D of J. So for an index term which does not appear in the document, so their weight will be 0. Weight of that I and J. What I represents is the index term, J represents the document. So with the document J, D of J is associated with an uh, order term. So vector D of J represented by D of J is equal to W1 J, W2J, W3J, W4J, W5J, WTJ. So these represents weight of the entire vector. So you can see in the next slide. So there are so many documents. So it is translated into a vector space representation. And of course, this is a term document matrix. So like this, you will have the many vector spaces. So that will be certainly used. Of course, the same thing. So further, let G be a function. Look at here. Let G be a function that returns the weight associated with the index term K of I in any t-dimensional vector. So that is Gi of dj is equal to wij. So that is what we can certainly understand. So the weight of ij is nothing but G of I with respect to document J. So G is a function that returns the associated weight. So weight of that particular K term, K of I term. So that is the concept that you should understand. And you can understand here as we later discuss, the index term weights are usually assumed to be mutually independent. They are completely independent. Uh, this means that knowing the weight of I and J associated with the pair K of I and D of J uh, will tell nothing about the weight of I plus 1 and J. It is not, you are talking about the regression model in machine learning, regression analysis. So it cannot be applied. Regression analysis, you cannot apply. So the weight of one uh, document and weight of the other document are totally independent. So you cannot apply regression. Of course, they are associated with the pair of ki plus 1 and dj. Ki is different, ki plus 1 is different. So totally different, index terms, different, weights they will have. This is clearly a simplification because occurrence of index terms in a document are not uh, uncorrelated. So consider for an instance that term computer and network are used to index a given document which covers the area of computer networks. Frequently, in this document, the appearance of one of these two terms attract the appearance of the other. So thus, these two words are correlated, and their weight could be, reflect in their, correlation. So while mutual independence seems to be a strong simplification, it does simplify the task of computing index term weights and allow for fast ranking computation. Furthermore, taking advantage of index term correlations for improving the final document ranking is not a simple task. In fact, none of the many approaches proposed in the past have clearly demonstrated that the index terms correlations are advantageous, especially for ranking purpose in with general collections. So therefore, unless clearly stated otherwise, we assume mutually independent among index terms. Maybe in the next chapter, we discuss modern retrieval techniques based on correlation and uh, which have been tested successfully with particular collection, not with all the collection. These successes seems to be slowly shifting the current understanding towards a more favorable view of usefulness of term correlation for information retrieval system. So above definition provides support for discussing three classical information retrieval models. So, namely Boolean, vector, and probabilistic models. So, that we will deal in the next session. So, tomorrow also I'm planning to conduct one session in the evening, the same time. Anyhow, tomorrow morning I'll give the message. And for this preparation, I have referred all these things. This is your textbook I have referred. And along with that, I have referred one more text book, reference book by Christopher D. Morning and Prabhakar Raghavan. So I have just used it. So thank you for giving your patient hearing and of course, so so any questions, if you want to interact, you are free to interact. You unmute and you can certainly ask. So any questions? Yeah. If not, so you can certainly type in your USN in the definitely. Prasum Tiwari, I will be sharing the notes. Anyhow, few more concepts I need to modify, and I'll send it. Latest by tomorrow, you will get the notes. You'll get the notes, and whatever we discuss, all these things are there in the notes. So don't worry. And of course, please type in your USN in the chat box for attendance sake. So thank you. Have a wonderful weekend. So anyhow, so we are doing along with our enjoyments, we are also doing the learning. We are also learning. So that is a good thing. So since I know most of you are working in internships, you may not attend the classes, but try to attend the online classes at least, so that you get some idea. When you start reading, it helps. So that's all. Have a great day. Thank you.